Hi everyone, Alejandro here from TP-Link once again, and welcome to another episode of our Omada video tutorial series. Last time we took a look on how to configure PPSK to give each client their own personalized password and place them in their own network. Today we're going to take a look at heat mapping, a tool embedded into the Omada controller that will help you visualize your next deployment and how to coverage every area based on a floor plan that you can upload into the controller. So let's go. Okay, so the first thing we're going to do is we're going to log into our controller and go to our site. Once you're in your site, you can access the heat mapping tool by going down here to map and then heat map. Now this feature is embedded into every kind of controller, and we also have a web version in our website that you can access. One thing we're going to do first is we're going to add our new floor plans. We're going to give this a name of heat map. We're going to browse for this. We're going to add it. Once you have added your floor plan, you can start editing it. To do that, we're going to go to, of course, the edit button. And the first thing we're going to do is we're going to add walls. Here you have a button that will allow you to do this. We already have some predefined walls already into the tool. If there's any wall materials that you don't see here but you would like to use, you can always add a new wall as long as you know the attenuation levels for each band. If you do, just give it a color and just create it. For now, we're going to use concrete for the outer walls of this floor plan. So we're going to start by just drawing a line. You just click and then click on the next spot that you want to make a turn. So I'm going to click there, then down here, then here. And I'm just going to do this throughout the whole outer area of these floor plans just to make sure that we have everything covered. You can right click to cancel a wall. Now that we have drawn the outer walls, you can see them here. We're going to draw every internal wall as wood or drywall. So we're going to go back here to our walls. We're going to choose wood. Let's minimize it. And now we're going to start drawing some internal walls. Of course, depending on the floor plan, this might take a while. All right, so after you have drawn all your walls, you are ready to put some access points in. So access point obviously is going to vary depending on the requirement. For this case, we're going to use an EAP 670. We're going to go here to virtual devices, and then we're going, you can search it here, 670 EAP 670. So we're just going to drag and drop it. If this is too big for you, you can always change the size of the AP icon like that. One thing I did draw over any wall, any doors, because you can always assume that the door could be closed. So I'm planning for the worst case scenario where every door was going to be closed. So we're going to put our first access point here in the great room, and at this point we're just going to click here done, and we're going to simulate it. You can see how the radiation pattern changes depending on walls, how walls are going to degrade the signal depending on how many there are. So one single access point here is most likely able to cover this whole area. Now, one thing that I like to do, and it is something you guys should consider, is to always have at least minus 67 dBs of signal strength in reference to 2 access points. This is to ensure that in case of one access point drops, you will still have another access points to fall back to. So right now I only have one access point here. This is the 2.4 band. So I'm going to go here to the 5G and I'm going to simulate it. You can see here that the 5G will not penetrate through walls as efficiently as the 2.4. So after you have simulated your radiation pattern, if you toggle this show signal strength button on, you can see the signal strength from the tip of your mouse in reference to any of the deployed access points. Since right now we only have the one, it would seem that this access point will be able to give you a coverage of minus 67 anywhere. What we're going to do is we're going to edit it, and we're going to do some adjustments to the access point itself. It is not recommended to transmit at full power on your access points, because the transmit power varies depending on the channel. So what I'm going to do is I'm going to do about 75 to 80% of the total transmission power. Here I'm going to do maybe 20 dBs. Same for here. Up here, you can define how your access point is going to be installed. If it's ceiling mounted, if it's sitting on a desktop, if it's a wall plate access point, if it's mounted on the wall, or if it's an outdoor. In our case, I'm going to assume that this is a ceiling mount access point and it's mounted at your standard 3-meter height. The angle of the access point refers to where the LED is pointing. The radiation pattern of the access point is not a perfect circle, so it's going to be a bit larger at the front of the access point. So you make sure to change this angle however you prefer if you want to edit the orientation of the access point. So we're going to save that. And now we're going to click done. We're going to simulate our 2.4 again. Then we're going to simulate the 5G. I'm going to reduce my sensitivity to minus 67 dBm, which is what I'm hoping to get. So now you can see that with just one access point on the 5G, there's a lot of gaps here in the garage area that are not fully covered. If I turn my show single strength here, you will notice that here I have no values. Right now here in this section, I'm already minus 67 on my threshold. So I want to add another access point here for local garage Wi-Fi. So what I'm going to do is I'm going to turn this off, and I'm going to go back to edit mode. Now here I'm going to add a wall plate access point. So I'm going to go here to devices. I'm going to type here wall. Now here we have all in-wall access points. I'm going to put a 615 wall and here. I'm going to put it as close to the wall as we can. There. We're going to do the same. We're going to call this garage. Now the height, I'm going to put that it's mounted at about 1.5 meters. The angle is going to be pointing towards this side, so I'm going to change this to 270. And I'm going to lower the transmission power to about maybe 17 dBs. Here, 17 dBs. Apply it. I'm going to close it. And now we're going to simulate our heat mapping again just to see how that looks. So simulate here. Here we have the 5G. This is how the 5G will look. If we turn our show single strength indicator, now I can only see one of the access points. So what I'm going to do is I'm going to move this one to the bottom. I'm going to change that. Edit. I'll move this one here. This is probably the entrance, so I cannot put it on the door. So I'm just going to put it on this side and see how it looks. I'm going to edit the orientation to 90 degrees. Apply. Done. Simulate. There. So now if I show my signal strength, I'm going to have a good coverage coming from both access points. Now here I only have coverage from one of the access points, and I'm getting very close to my signal threshold there. So I'm going to put another wall plate access point here in this guest bedroom, since it's most likely that it's going to be needed in this spot. So I'm just going to go back to edit mode. What I'm going to do is I'm going to grab this guy, and I'm going to copy to map, and I'm going to put it right here. There. I am going to edit its orientation. Apply. Great. So let's see how that looks now. It's starting to look better. So keep in mind that this is the 5G. We still have good signal all around premises. Right, let's see how the 2.4 looks. And that's fairly it. This will give you a fair good idea on how much access points will cover, as long as you define the distance settings right, as long as you define the materials of the walls right. You'll have a very good approximation to the actual coverage of our access points, and you'll have an idea on how many to use. From here, you can then export this into a file, and this will generate a Word document with all the details, all the channels that you have selected, the height, everything that you have defined already here will be imported into a report that you can share with your customer or keep with yourself for your reference. Great work. Now you know how to use heat mapping to optimize the placement of your access points and the overall coverage of your Wi-Fi network. In the next episode, we'll dive into mesh and how to wirelessly connect multiple access points with each other to further expand your Wi-Fi coverage and have a more broader resilient network. See you there.